Just as a quick review, graphing lines, we talked about, we did it last year, we reviewed it this year, table of values. How to use a table of values to graph a line. So if I said y equals negative 4x plus 2, you don't have to write this down, you can just, we want to make sure y is by itself, which it is, then we make a table. And if there's a fraction, we got to be careful of the x's we pick. But if there's no fraction, then we can just put 0, 1, and 2. Plug all these in and calculate for y, and you get 2. Negative 4 times 1 is negative 4, plus 2 is negative 2. Negative 4 times 2 is negative 8, plus 2 is negative 6. And then we put them on the graph. 2, negative 6, and we see that the 3 points form a line, and we draw a line through. New method we talked about at the end of last term were the intercepts. Where we find 2 points and draw a line through them. And intercepts work well with equations that aren't solved for y. So if I said 2x minus 3y equals 6. Well, you could solve for y and then do a table of values, but the intercepts would actually be pretty quick here. So we want to find two intercepts, 2 points, where the line is going to cross the x, where the line is going to cross the y. And wherever it crosses the x, the value of y is always 0. And all you have to do is look at any point on the x-axis, the y coordinate is always 0. And then it's the reverse, finding the y-intercept. Any point that goes through the y-axis, the x coordinate is always 0. So we have to do some algebra. So I'm going to plug in 0 for y. Well, minus 3 times 0 is nothing. So I'm left with 2 times 6 equals, or 2x equals 6. That means it's going to cross the x-intercept, or the x-intercept is going to be 3. Which means our line is going to cross the x-axis here. That's 1 point. Now we got to go back and find the y-intercept. So I'm going to make x 0. Well, 2 times 0 is nothing. Negative 3y is equal to 6. So the y-intercept here is negative 2. Which means that our line is going to go through the y-axis at 0, negative 2. Got my 2 points. Draw a line through. And just remember, if we've got an equation that, say, just has x in it, an equation that just has y in it, these are special types of lines. This will be vertical, always. So I find x at 1, which is here, and draw a vertical line. If it has just a y in it, it's going to be horizontal. So I go on the y-axis, I find negative 2, and I draw a horizontal line. Okay. So just an x, it's vertical. Just a y, it's horizontal. If it's got both an x and y, it's going to be slanted. And you've got different methods. Table of values, the intercepts, and the one we're going to do today. Okay. Just remember when you ask to draw the lines of these things, they're lines. Some students will put the point and then they won't draw the line. Okay. Hi, Juna. How are you? Super. Okay. So let's get to this one, which is the third way to graph lines besides table of values and intercepts. And usually this is the most efficient way. Okay? And this is the way that's commonly used. So let's say you were asked to graph the line y equals negative 2x plus 2. We could have graphed it using the table of values, could have graphed it using the intercepts method. Regardless, this is what it looks like when we graph it. Okay? Couple of questions. What's the y-intercept of this line? What y value does it go to? Oh, come on, that's an easy. Where does it go through the y-axis? The line. Here, right? What's the y-coordinate here? What point is this? 0, 2. So 2. It's the y-intercept. Slope of the line, well, we have to do rise over run. So we pick 2 points. So let's say I'm going to pick these 2 points. And I got to figure out how much I rise and how much I run. Well, to get from here to here, I've got to go down 2. So that's negative 2. And then I've got to go across positive 1. So the slope of the line is going to be negative 2 over 1, or just negative 2. Notice anything? Thank you. The y-intercept is the last number in the equation. The slope is the number that's in front of x. That's always the case when the equation looks like this. Okay? So whenever you have an equation that takes this form, y equals mx plus b. That's called the slope-intercept form. You can read, you don't have to calculate anything, you can read 2 pieces of information off of it. The number at the end of the equation will always be the y-intercept when you graph it. Whatever's in front of the x, we call m, that's going to be the slope of the line that you're trying to graph. And this is enough information to graph the line, because all you have to do to graph using this method, put this on your graph, put this point, and then count out a second point using the slope. So I'm going to actually skip to this example. We're going to do example 1, but I want to show you this one first, how it works. So when you graph using this method, first of all, you have to ask yourself, is it in this form? Y equals mx plus b. Well, yeah, y equals some number x and then some number at the end. So yes. If it's in that form, b is going to be the y-intercept, which is going to be what number? N is going to be the slope, which is going to be which number in the equation? What number? Where's M? Yes, 1/2. So to graph it, plot the y-intercept. So our line that we're trying to graph crosses the y-axis at 3. We've got 1 point on our line, but we need 2 points to graph the line. Use the slope to count out a second point. Count out a second point. So from the y-intercept, because it always has to be from the y-intercept. So from the y-intercept, so from here, this is telling me to rise 1 and run 2. So from here, I'm going to go up 1, go to the right 2. There's a second point that's on the line. Draw through. Whenever an equation is solved for y, this is much quicker than a table of values. Much quicker. Okay? I mean, table of values is still good. It's still valid. Okay? But we should really get used to using this. And actually, we can use this formula another way too, if I asked you to work backwards. What if I told you stuff about the line and asked you to write the equation? Okay, all the questions we've done to this point, I've given you the equation. You've been asked to graph the line. What about if we go backwards? I give you some stuff about the line, or I give you the line and ask you to find the equation. That's like example 1. Don't overthink this. So we're going to use this formula, the slope-intercept form, to find the equation. M represents the slope. What's the slope of this line? What does it say in the question? 3/5. So I replace M with 3/5. I don't replace Y and X with anything. And I replace B with the y-intercept, which is -4. That's it. You're done. So that's actually what we're going to do to finish off this unit starting next week, is how do we go backwards? Like if I give you information about the line, how do you write its equation? Okay, which is actually a very important skill. Instead of telling you the y-intercept and the slope, this time I've given you a graph and asked you to find the equation. Well, to find the equation, we're going to use this. And I've got to fill in the slope for M and the y-intercept for B. And I've got my equation. Well, let's use the graph. What's the y-intercept? Looking at the graph. Where does this line cross the y-axis? Where? Where does this line cross the y-axis? Well, I'm going to wait all day for this one. -4. So the y-intercept, or B, is -4.
And the slope, I'm going to use rise over run. Take 2 points, count out the rise and run. So let's take these 2 points. Well, I have to go down 3, and then to the right 2. So the slope is -3/2, which means the m is -3/2. I got my 2 pieces. Just replace them in the equation. Y equals -3/2 x minus 4. You've got your equation. Okay. Last question is the following. If you remember, this course is called Applied and Pre-Calculus Mathematics. The stuff that we just did is the pre-calculus stuff. Okay? It wasn't in any kind of real-life problem, was it? Applied is when we actually put them into problems. Okay, real-life situations. So now we're going to do an applied portion using what we've just learned. Okay, and it's a pretty straightforward example. So the student council sponsored a dance, which they don't have here anymore. A ticket cost $5 and the cost for the DJ was $300. I want to write an equation to calculate the profit, which is called P, based on the sale of tickets, which is called little t. How would I calculate the profit? How much does it cost for each ticket? $5. So that means however many tickets I sold to get them, how much I made, I times it by 5. But then I got to pay the DJ. So am I adding 300 or am I subtracting 300? I have to pay the DJ. Isn't that coming out of my profits? Minus 300. We did questions like this last year. And notice that this actually is in the form y equals mx plus p. It's just instead of y and x, we've used capital P and little t. So you could actually graph this situation to show how your profit changes over time, right? But we're not going to do that here. We're going to use this equation to answer some questions. Right? Well, let's say 120 people bought tickets. What was the profit? Is the 123, does it represent T or P? Really? T. So to calculate the profits, I'm going to go 5 times 123, but then I got to subtract what I'm going to pay to the DJ. And what's 5 times 123? 615. Can somebody do that just to make sure I'm right? Okay. You're going to make a profit of $315. Part C, you're told the profit was $350. You have to figure out T. So for part C, we are told that P is $350. We have to figure out what
T is something. No, never mind. Never mind. I was out thinking this. So we've got to solve this equation. Well, I got 5t on the right already, so I'm going to add 300 to both sides. And we get 650 is equal to 5t. And then I'm going to divide both sides by 5 to get t by itself. And 650 divided by t should give me another. And finally, can the profit or could the profit be exactly $146? Or in other words, how many students attended so that the profit works out to exactly 146? Well, all right. Wouldn't I just do the same thing as C, except this time put in 146. Add 300 to both sides, and you get 446 is equal to 5t. Divide both sides by 5. Oh, they have to help me on this one. 88.2. Shoot. 89.2. Oh, yeah. Okay. Does that make sense? It does. Really? Would you like to maybe take the rest of this period and go out into the community, or go in this school and find the 0.2 of a person? Okay. But never mind half a person, 0.2 of a person. So no, you can't. It's impossible. You can't make 146 bucks because you can't have 0.2 of a student. So no. Oh, you just no, because you can't have 0.2 of a person. Student. Okay. Okay. Big thing I want you to get out of this one right now, this lesson, is how to graph using this formula. Okay. That's what I want for now. But we are going to do more sort of word problems.